Welcome back. The purpose of this video series is to cover dimensional analysis, or you may know it as unit conversions. So, you may want to go back and review the metric systems video where we talked about the base units for length, mass, and volume, as well as your most common prefixes used in general chemistry, because we will continue to use this in the video series ahead. We also talked about a roadmap where you start with given information and you are looking for what we call the target, and that's what the question is asking you to solve for. And in between, we're going to use what we call conversion factors. Now, the given information, we want to spot it as the standalone unit. Okay, so units that have slashes, such as density values, are going to be in typically grams per milliliters. That's got a slash in it, and so that's going to indicate typically a conversion factor. Okay, we may also have an equality, and so when we look at those metric system prefixes, we can see that we have an equality between two numbers and two units. Or you could have a phrase such as there are so many feet in a mile, or there would be so many milligrams in a dose of a certain medicine. Okay, so you've got to look out for those phrases that may contain more than one unit. Conversion factors could either have to be memorized. Those are your metric system prefixes or your constants, and please check with your instructor so you know what you need to memorize for your class. And then conversion factors can be provided in the question. Okay, and again, it's going to be anything that contains the slash, equals, or phrase, because those are not going to be your given units. And then the target is, of course, what the question is asking for. So remember in general that when we had a one-step unit conversion, we always, for our conversion factors, would place the target unit on top, and underneath would go the given unit. And those would come from the conversion factor itself. Okay, now because we are going to be dealing with multi-step dimensional analysis problems, it may not be that simple because your given and your target are going to constantly be changing. So instead, it may be easier to think of putting the right side of the arrow, so right units on top, and then left units on the bottom. Left being your given information or the last thing that you used. So when we're talking about right and left, we are talking about right and left based on the arrow. And it's the arrow in our roadmap. Okay, so let's go through some examples of this. In the first example, the distance between the centers of the two oxygen atoms in an oxygen molecule is 1.21 times 10 to the negative 8th centimeters. What is the distance in inches? Okay, sometimes the easiest thing to find is the target. What is the question asking for? And it's asking for distance in inches. Okay, so I'm going to go ahead and label that as my target, and typically I will write it down in my roadmap on the far right hand side, so I leave myself plenty of space. Okay, and then we need to figure out what the given information is. Remember, the given information is going to be a standalone unit, which is the 1.21 times 10 to the negative 8. It cannot contain a slash in the units, and it cannot contain an equality sign. So that phrase at the end, 2.54 centimeters equals 1 inch, that must be our conversion factor because of the equality sign that separates those two numbers. Okay, so we've located our target, our conversion factor, and so the only information left that has a standalone single unit of centimeters, that must be our given information. Okay, so I'm going to start with the given information on the far right-hand side. And of course, I'm leaving way too much room for this problem, but you never know how many steps it is until you look at all the conversion factors that you may need. Now, If my conversion factor contains the units that are given as well as the target units, all in one conversion factor, then this is a one-step process. And thankfully, that's what I see, right? My given units are centimeters, my target unit are inches, and then in the conversion factor that I have, I've got centimeters and inches. So since they're both contained in a single conversion factor, this is a single step process. And underneath that arrow, I can write the 2.54 centimeters equals 1 inch. Okay, now I'm going to set up the dimensional analysis, always starting with the given information, 1.21 times 10 to the negative 8th centimeters times my conversion factor, and here's where I want to put from the conversion factor the units that are on the left need to go on the bottom of the fraction. So left of arrow units, those are my centimeters, those are left of the arrow, and so from the conversion factor underneath, I'm going to find the 2.54 centimeters and place that underneath the conversion factor. So 2.54 centimeters goes on the bottom, and then on top are my right of arrow units. Okay, so in this case, that's my target, which are the inches. So I go back to the conversion factor, find inches, and put that on top. And remember, the number and the unit have to stick together. Okay, so centimeters cancel, and I am left with my inches. Sig figs, the given information has 3 significant figures. Okay, all from that coefficient. And then the conversion factor, all of the numbers in the conversion factor are considered exact. Remember that 2.54 centimeters equals 1 inch is an exception to the rule. Typically, the US and the metric system conversions are not exact, but in this case, they are. Okay, so we need 3 sig figs in our answer, which leaves us with 4.76 times 10 to the negative 9th inches. Okay, so again, remember, I am writing down my given, my target, my conversion factor underneath the arrow, and when I build that conversion factor as a fraction, I'm going to put the units that are to the right of the arrow on top and the units to the left of the arrow on bottom. But all of the numbers have to come from the conversion factor underneath that arrow. Okay, so let's try another example. Many chemistry conferences have held a 50 trillion angstrom run, and they want to indicate that 50 is 2 significant figures. So this is technically 50 with a decimal, and then trillion is represented by 10 to the 12th. Okay, and you would have to ask your instructor if you need to have that memorized or not. But trillion is 10 to the 12th, and angstrom, the symbol that we use, is an A with a degree symbol over it. How long is this run in kilometers? And then they tell you how many meters are in 1 angstrom. So again, target tends to be the easiest. They are asking, what is the length of this run in kilometers? So on the far right-hand side, I'm going to go ahead and put question mark, kilometers. Okay, so that's my target. Then I've got to find my given versus the conversion factors, right? So 50 trillion angstrom run, that is a standalone unit. It's not part of a phrase with another unit. There's no slash or equality. But here in parentheses, we do have that equal sign, okay? And that equal sign indicates that that is a conversion factor. So that means that 50 trillion must be my given information because it's the only number left. Okay, so on the far right, I'm going to start off with that 50 trillion, 50 times 10 to the 12th angstroms. And then here, when I look at the conversion factor, it doesn't contain both the given and the target units, right? It only has the given units that match. So I'm going to line that up next to the given information as 1 angstrom equals 1 times 10 to the negative 10th meters. Okay, so I know that that's got to be my first step and my first conversion factor because the units line up with the given units. Now, I can tell what it's going to lead me into because other than the given units in the conversion factor, the other side has the meter. So that's going to lead me in to finding how many meters there are in that many angstroms. So I must find a bridge now between the meters and the kilometers. And if it's not given in the question, then chances are it's something that you have to have memorized. And this goes back to our metric prefixes, right? So 1 kilometer, we know, is equal to 10 to the third meters. Okay. So if we set this up, starting with our given information, we've got 50 times 10 to the 12th angstroms. And then looking only at my first conversion factor, remember that I want to take the units that are on the right, match those up, and they need to align diagonal underneath the fraction. So if I am starting with angstroms, then from my conversion factor, that 1 angstrom needs to go underneath the conversion factor. And that forces the other side of the equality, 1 times 10 to the negative 10th meters, to go on top. So my angstroms cancel. I'm going to multiply by my second conversion factor now. And again, on the left side of the arrow, I am starting with the meter now. That's the only unit that didn't cancel. And so from my conversion factor, I'm going to take the times 10 to the third meters and diagonally put that underneath the conversion factor so that my meters can cancel. And that forces the other side of the equality, the 1 kilometer, to go up top. Okay, so notice how I'm always keeping that unit and that number stuck together. Okay, so sig figs, 50 with a decimal. They've already told us that this is 2 significant figures. And then everything else is considered exact by definition. Okay. So our final answer needs to end with 2 significant figures. Your calculator will probably just give you a 5, but we must make it 5.0 to give it that 2 sig figs. And then kilometers are the only units that we did not cancel out. Okay, so I hope this helps. In the next video series, we're going to pick up with more dimensional analysis, looking at density as a conversion factor.